Hello everyone, welcome to the lesson. This is a question on velocity time graph, Kcse Mathematics 2009, paper 1, question number 22. The question reads, the diagram below shows the speed time graph for a train traveling between two stations. The train starts from rest and accelerates uniformly for 150 seconds. It then travels at a constant speed for 300 seconds and finally decelerates uniformly for 200 seconds. So there we have the diagram showing the speed in meters per second and time in seconds. Given the distance between the two stations is 10,450 meters, calculate the A, maximum speed in kilometers per hour the train attained, B, acceleration, then C, the distance the train traveled during the last 100 seconds, and then we have D, the time the train takes to travel the first half of the journey. So those are the questions. Let's go straight to the first part. Before we go to the first part, it's important to note some important things here. So the train starts from rest and accelerates uniformly for 150 seconds. So there's something that we need to draw here. So I'm going to draw some height. So I'm going to draw some heights here. So where it accelerates, so there's a height that I'm going to draw there, and then the same height there. So doing that, this train accelerates uniformly for 150 seconds. So where does it accelerate? The point at where it accelerates is this point, and this we have 150. Let me write this on well. So 150 is here. Then travels at a constant speed for 300 seconds. So you can see where the speed is constant, where we have a straight line. So from here, this is where we have 400, this is where we have 150. Then when you add this distance, so this one will be 300 seconds. So then decelerate uniformly. Where does it decelerate? You can see where the graph is moving down. This is where it decelerates for 200 seconds. That is why I have 200 seconds. So after drawing that and having that information inserted there, we can go to the first part of the question. Given the distance between the two stations is 10,450 meters, calculate the maximum speed in kilometers per hour the train attained. Now we're given the total distance that this train traveled. We need to get the speed. Now this one is a velocity time graph, where we have the y-axis, we have speed, then the x-axis, we have time. So it is a velocity time graph. Now in a velocity time graph, if we get the area under the curve, or the area under the graph, that is the one that gives the distance, the total distance traveled. So we need to divide this area in three sections. You can see here we have a triangle. We can call that area A. Then you can call this area B, and this one you can call this area C. So when we get the area under that graph, that is the area of the two triangles and one rectangle, as you can see, it will give the total distance. So that is what we need to get. We know how to get the area of a triangle. The area of rectangle is Z. So we already have the lengths, which are represented by this time, and what we don't have is this height. We don't have the height, so we don't have that height. And to get that height in a velocity time graph, that height is the one that represents the speed. That is the speed we want to calculate. So we are required actually to get the height, and the height is the speed. So to do this, we just need to use this concept that I've given you, that to get the total distance traveled in a velocity time graph, we do get the area under the graph. the total area under the graph. So to do this, we shall get the area of this triangle A, then plus the area of rectangle B, plus the area of rectangle C. That will give the total distance. So let's go straight and do that. We do that. So the area, so that is a part A. So the area of these, let me get it here. So the area of a triangle A will be a half base times height, which is a half times 150 times the height. That is a triangle. So the area will be given by a half times the base, which is 150, times the height, plus in the middle there you can see this one is rectangle. So that rectangle B, the area will be length times width, which is a 300 times h. So 300 times h. Then the last one which is C, that one is a triangle. So the area will be, the height is the same, so a half base times height, half times 200 times the height, so a half times 200, so half times 200 times the height, and these should give the total distance the train covered, and given that distance is 10,450. Now we need to work out these. So these will give 75h plus 300h plus this is 100h. You should give 10,450. When you add these, you get these will be 475h is equals to 10,450. Then h will be given by 10,450 divided by 475, and this one will give the height. If you work out this one using a calculator, let me just calculate these. This will give 22 meters per second. So that is the height, and the height in this case represents the speed. So the speed is 22 meters per second, but we should give these in kilometers per hour. So how do you convert meters per second to kilometers per hour? To convert meters per second to kilometers per hour, we simply multiply this one by, this is a formula that we use, and we need just to multiply. This is the easiest. For us to convert meters to kilometers, we divide it by 1,000. For us to convert again seconds, you know how many seconds make 1 hour? 3,600. So to convert the whole of these, we shall therefore multiply by 3,600 divided by 1,000. Why do we do this? To convert meters to kilometers, we divide it by 1,000. Then to convert seconds to hours, we're going to again multiply that one by 3,600. So that is what you're supposed to do. When you multiply these 22 multiply by 3,600 divided by 1,000, this one gives 79.2 kilometers per hour. So that is simply how we're supposed to work out the first part, by simply using that concept that to get the total distance traveled in a velocity time graph, we get the area under the graph. The total area under the graph gives the total distance. Part B, acceleration. Acceleration. So that is B. Now, what is acceleration? It is important to note this, that acceleration is the change or speed with time. The change of speed with time. Now we need to just look at this graph and notice that it accelerated at this part, look at that shape. This is part where it accelerated. That is why it traveled for 150 seconds. That is part A. That is where it accelerated. Now we already have the speed. We've got the speed. The speed is 22 meters per second. Then we should divide that with the time. So we have the speed. We've already obtained the speed. The speed was 22 meters per second when it was accelerating, and that time where it accelerated, it used the 150 seconds. So when you simplify this one, you get 11 over 75 meters per second squared, or you can simply convert this one to decimal, and when you convert 11 divided by 75, this will give 0.1467 meters per second squared. So that is simply how you're supposed to get acceleration. Change the speed with time, and we've got the speed is 22 meters per second. Then at the time where it accelerated is simply 150 seconds. So let's go to the other part of the question, which is part. This is part C. The distance the train traveled during the last 100 seconds. The distance the train traveled during the last 100 seconds. Now, during the 100 seconds, we need to get this is the place. So it is exactly between this triangle. Look at triangle C. So the last 100 seconds will go up to, let's say, up to this point, that point. So you notice this one will form another triangle, so that this one will be 100. And then when you look at this height, this will be exactly at the center here. So we have this triangle that is here. May name this one as triangle D. This is the last 100 seconds. This is the point where it was decelerating uniformly. Now we already have, if we can extract it here, so this one is 100, and then there's something here we can get. You can see, because this one is exactly at the center of the last 200 seconds. So if we divide this one like this, you will get the height as 11. So this height will be 11, and this one will be 11. So this will be 11, the speed, since the whole height here is 22. So when you divide it into 2 here, this point, because this one is exactly at the center here where you have 200, so you'll have this one as 11. Now to get the distance, we just stated that in the first part. Get the distance it traveled during the last 100 seconds. We said to get the distance in a velocity time graph, we just need to get the area under that graph. So when we get the area under this triangle, this is the part where we have the last 100 seconds. So when you get the area under this triangle here, which I've extracted here, that will give the distance it traveled for the last 100 seconds. So this one will be a triangle, that shape with a triangle with the base 100 seconds, then the height, which is the speed, is 11. So we just need to get that. So it will give, so part C, that will give a half times the base, which is 100, times the height, which is 11. And these will be very easy. This will give 550 meters. That is the distance it traveled the last 100 seconds. The last question, the time the train takes to travel the first half of the journey. The time the train takes to travel the first half of the journey. Now let's go to the diagram here. Now for the first half of the journey, we can try to divide these. We try to divide these into 2 like this, because this will be the first half of the journey. So if I divide it like that, and this is exactly at the center of that trapezium. That will represent the first half of the journey. So what we have already is we have this distance 150, that is 150 seconds, that is the time, first time. Then we don't know this time from 150 to where we have the first half of the journey reaching, we don't have that. So we can simply let this one to be represented by t, since we don't have these. So let me read this one properly. So we can let this one to be t, or something's wrong here. So we can let this to be t and this one to be t. So we don't know exactly the time it took up to from 150 to where the first half of the journey ends. So we can let that time there to be t seconds. So the first half of the journey, if the total journey is 10,450, then the first half of the journey we just need to multiply by a half. That is the distance that will be traveled for the first half of the journey. Just take the total distance, instead of the total distance traveled between the two stations is 10,450. So the first half of the journey will be a half of that distance, and this one will be given by, so let me write it here down. I just need to write it down here. So the first half of the journey, half times 10,450, and this one will give let me just calculate this. The first half of the journey will be 52.25. 52.25. That is the distance that you should use. So that means using the same concept we used in the first part, the same concept, that if you want to get the total distance in a velocity time graph, we just get the area under that graph. So we'll get the area of the graph up to this point where I've drawn this line. So this is the place this is the area that you need to get, and this shape is a trapezium. So if we get the area of that trapezium up to that line that I've drawn there in red, the area will give us the total distance, which you've already got, 50.25. So this one being a trapezium, how do you get the area of the trapezium? The area of the trapezium is given by, you already know this, is a half times the sum of the two parallel sides times the height. That should give us that distance, 25. So we have a half times, we have the height. The height is the speed, which is 22. Then for the distance between the two sides, the distance of these parallel lines, we have 150 plus t plus the other t. So here below we have 150 plus t, then at the top there we have t. 150 from this point to this point, that is 150 plus t, then there is a plus t. So that will give 150 plus t plus t. So 150, this is a parallel sides, plus t plus t. That should give 52.25. This one will give 11. This one will give 11. 150 plus 2t is plus 2t is equals to 52.25, like that. So from there, let me add a page here. So from there we can simplify 11 multiplied by 150 will give 11 multiplied by 150. This one is 1650 plus 22. It will be 22t is equals to 52.25. So 22t is equals to 52.25. Subtract 1650, which is 22t is equals to, when you subtract these 52.25, subtract 1650, give that 575, then divide both sides by 22, you get t is equals to 35.75 divided by 22. 35.75 divided by 22, this one will give 162.5. 162.5 seconds. Now that is the value of t. Now what we've got, we need to know what we've got here. What we've got is this t, so this one was 162.5. so therefore the time now it took to cover the first half of the journey will be all the way from the beginning, from 0 here where it began up to this point. So this distance will be given by 150 plus t, which is 162.5. so to get that, we just need to add these. So time therefore will be given by 162.5 plus 150 where it started, and this one will give 312.5 seconds. 312.5 seconds, and that is simply how you're supposed to solve that question on velocity time graph.